Solve the initial value problem dy dx equals 2xy minus x, where y of 0 equals 4. Again, we're going to solve this using method 1. To better see what the complementary equation is for this problem, we should first rewrite it in the standard form y prime plus p of x y equals f of x by subtracting 2xy from both sides. So the complementary equation is dy dx minus 2xy equals 0, or dy dx equals 2xy. Separating variables, we get that dy over y equals 2x dx. Now integrate both sides. Natural log of the absolute value of y equals x squared plus c. Solve for y. Go through this quickly since we've done it a few times already. Absolute value of y is e to the x squared plus c, so y is a e to the x squared. That's our complementary solution. Again, our simplest choice for y1 is y equals e to the x squared. So we'll substitute that y equals u times e to the x squared into the original equation. In this problem, y prime equals u prime e to the x squared plus u times 2x e to the x squared. Plugging into dy dx equals 2xy minus x, we get that u prime e to the x squared plus u times 2x e to the x squared equals 2x times ue to the x squared minus x. Again, we can cancel the terms with u, not u prime in them. So that's a good sign, leaving us with u prime e to the x squared equals negative x. To solve for u prime, divide both sides by e to the x, which can never be 0. Next, find u by integrating, which requires substitution. So u is going to be the antiderivative of negative x over e to the x squared dx. I'm going to let t equal x squared. So dt is 2x dx, which means that x dx is 1/2 dt. So u is equal to the integral of negative 1/2 times 1 over e to the t dt, which I can rewrite as negative 1/2 antiderivative of e to the negative t dt. Integrating, I get 1/2 e to the negative t plus c, which is 1/2 e to the negative x squared plus c. Finally, substitute back into y equals u times e to the x squared to get that y equals 1/2 e to the negative x squared plus c times e to the x squared, which we can rewrite as y equals 1/2 e to the negative x squared times e to the x squared plus c e to the x squared, which equals 1/2 plus c e to the x squared. So our general solution is y equals 1/2 plus c e to the x squared. But even though we did all of that work, we still aren't quite done yet because this is an initial value problem. We need to use that y of 0 equals 4 to find c. Plugging in 4 for y and 0 for x, we get that 4 is 1/2 plus c e to the 0 squared. So 4 is 1/2 plus c e to the 0, which is 1/2 plus c. So c is 4 minus 1/2, which is 7/2, which we can plug into our general solution to get our final answer, y equals 1/2 plus 7/2 e to the x squared.